All right, this last video is probably going to be the trickiest of them all. Let's see. How do we deal with roots? Okay, I'm gonna write roots over here, like the cubed root, the fourth root. Okay, so it'll say something like the cube root, or it'll say the fourth root. Okay, so what these are just fractional exponents. So the cubed root is like the end's going to be equal to 1/3. See, the exponent is going to be 1/3. The fourth root, the n is going to be equal to 1/4. Okay, so you might say, oh, well, that's not too bad. No, it's not terrible, you know. But let's say you had, well, let's just go over and look. Okay, so I'm going to grab a problem from the homework right now, and it says I want to find the cube roots of the square root of 3 plus I, right? So, well, the first thing I need to do is convert square root of 3 plus I to a polar represented complex number. So wait, what was they don't even give it a letter like W or Z. So I'm just going to put square root of 3 plus I, okay? And we're going to take the cube root of it. So here's our example where we want the cube root, okay? So, well, I see, and I always like a little bit of a drawing. I see I'm going out the square root of 3 and I'm going up 1. So this is my long leg, this is my short leg. And that means I've got a 30-degree angle. I recognize the square root of 3 down here. And then the hypotenuse is twice as big, so my magnitude is 2. Okay, so my angle is 2 cosine 30 plus I sine 30. All right? Okay, so what do I want to do with that? I want to take the cube root of this number. The cubed root of that number. That just is the same thing as having a 1/3 power. So I like the 1/3 power better because it is going to be the same DeMoivres theorem. This is called DeMoivres theorem down here. I forgot maybe to mention that. I thought it was in my notes somewhere, but it doesn't look like it is. DeMoivres is this guy that came up with this idea, and it's amazing that it works. So how do we do this? Well, when we had just a straight up like cube power, we raise the magnitude to that power. So I'm going to do the same right now. I'm going to take 2 to the 1/3 power, and then it said we multiply the power times the angle. Well, my 1/3 is my power, so I get the cosine of 1/3 times 30 plus, and I need a parenthesis here, don't I? Plus I sine of 1/3 times 30. Okay, what's that come out to be? But I guess you could write it like this, the cube root of 2, and then cosine 10 plus I sine 10. Now here's the bad news. Did you know that if you're taking the cubed root, you actually have 3 answers? If you're taking the fourth root, you have 4 answers. And quite often, like, I don't know, let's say you're taking this, well, let me jump over to Desmos here for a second. If I'm taking the fourth root of 128, I get 3.36. I was going to point something out with this, might as well talk about it. There should actually be 4 answers. This is the only real answer that we get, but there are, well, actually negative 3.363 would be that would be a real answer too, because if you raise negative, so we got 2 real answers, and then we'd have 2 with an imaginary component, and we'll talk a little bit about that. So what I wanted to point out here is that, you got the fourth root, the same as the 1/4 power. See how that works right there? Okay, so anyways, we'd have 4 total answers if we had a fourth root. In this situation, I've got a cubed root, so I need to find more answers. So where do the more answers come from? Well, it doesn't come from the magnitude. So let's put down here, this is like answer number 1. So this is like my x sub 0. That's what I'm going to call it. We're going to find an x sub 1, and we're going to find an x sub 2. That would make 3 different solutions to my problem, okay? So like I was saying, it doesn't come from the magnitude, so let's recopy the magnitude. So it's 2 to the 1/3 power, or the cube root of 2, okay? It comes from the angle. So let's think about this for a second. We were taking 1/3 of 30 right here, right? But it could be thought of as, oh no, 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 I don't want to delete all that. Woo, it came back. It could be thought of as, oh, doggone it, I did it again. I'm trying to get this guy to be a skinnier little eraser. Give me a second here. So let me see if I can erase this part right here where the parenthesis is, okay? So what I want to put right here is a third of 30 plus 360. I don't know if you can add that in on your problem, but it's a 30 plus, because if I had 360, I'm still back at this angle right here, right? So this was my 30-degree angle, but I could go all the way around, and that would be like 390, right? But now watch what happens. If we had 1/3 of 390, or we could go 1/3 times 30 plus 1/3 times 360, right? So we're going to add 120 degrees to the 10-degree angle. After you take a third of 30, right, you get 10. So my next angle instead of 10 degrees is going to be the cosine of 130. So I'm going to get cosine of 130 plus I sine 130. And then down here, I'm going to add another 120 degrees. So I get cosine of 250. Come on, Nelson. 250 degrees plus I sine 250, okay? So let's go over and let's try that right now on our Pearson problem. Follow me over, get number 7 ready to go. We've got a square root of 3 plus I, okay? So let's see if I can jump over there and write on that screen, okay? I think I can open up my tools here so I can write on there. So I'm going over square root of 3, I'm going up 1, right? This is the one that I was setting up a second ago, and I said this is 10 degrees right here and 10 degrees here, and then this was 2, but we're taking the cube root of it, right? So we want to put the cube root symbol of 2 in there. All right, so let's try that right now. Let me see if I can erase all this stuff here. Okay, it's not going to let me erase it. Give me a second here. Let me jump back over here and jump back over here. So I want the cubed root, put the cubed root right there of 2. And then here I want 10 degrees, and I want 10 degrees right there. And let's check our answer. Okay, that's good. Now we're going to get the same magnitude. So I wish I could copy that right there. It doesn't seem like I can right now. So I'm going to get the cubed root of 2, and then I'm going to get 130 degrees in there because we're adding 120. Why are we adding 120? Because a third of 360 is 120, so I'm adding 120 to get down to the next angle. Okay. Hey, one thing that I saw mess up some people is they want this to be as simplified as possible, the cube root of 2. So what I saw some people run into arithmetic-wise is like the 4th root of 128. Okay. Now, would you notice with me that like I could have in here 16 times 8, 16 times 8, that's the same thing as 128. So why am I doing that? Well, I can take the 4th root of 16. See, the 4th root of 16, let me get this out of here, 16 to the 1/4 power is just a plain 2. So because I can take the 4th root of the 16, I'm going to put 2 4th root of 8. Now that's not coming into play on my problem that I'm doing right now, because the cube root of 2, it's as simple as possible. So if you're missing your problem, it might be because you didn't simplify the radical. All right, so I'll maybe finish this off here. I'm going to go cubed root of 2 here, no simplification needed. And then I'm going to add 120 again. I get 250 and 250. And I hit check answer. Okay, now it's not a bad idea to click similar problem. Like you go back here, you can go and you can try a similar problem, I think, right? I don't know why mine's not doing it right now, but it's already giving you a similar problem when you click on it, right? So anyways, thanks for watching my video. I hope this helps you complete the assignment. Sorry I can't be here with you today.